In today's lesson, we're going to be graphing general rational functions. And to graph these rational functions, we're going to define it as a function f of x, where f of x is the quotient of two different polynomials, p of x divided by q of x, let's say. And they can be any polynomials. Now, the key to graphing these is knowing where to find your x-intercepts, and your x-intercepts can simply be found by solving for the zeros of p of x, which is the numerator, because 0 over anything is going to be 0. But also we need to be able to find the asymptotes, the vertical asymptotes, which can be found by finding the zeros here. In other words, when you divide by 0, will give you vertical asymptotes, and then horizontal asymptotes. And horizontal asymptotes are not quite as straightforward, but we have a little guide here where m is less than n when we're talking about m, and n is the exponents, or the degree of the polynomials. You're going to have a y equals 0. When m is equal to n, then it's going to be a horizontal asymptote located at a sub n, b sub n, basically the ratio of the leading coefficients of each polynomial. And finally, when m is greater than n, in other words, the larger the degree in the numerator is larger than the one in the denominator, then they'll have no vertical asymptotes. So thus, smaller on top, they're equal, larger on top. And this can be a little tricky to remember. So there's a little mnemonic here to help you remembering how to graph those horizontal asymptotes. And it's Bobo Botan eats DC. It sounds really nonsensical, but if you put it to a little tune, it becomes easier to remember. So if you remember, Bobo Botan eats DC, eats DC. This is how we find the horizontal asymptotes easily, easily. And so if you repeat Bobo Botan eats DC to, I guess that's Frere Jacques, it becomes easier. So here's what it means. Bobo simply means if you have a bigger exponent on the bottom, then n is equal to 0. In other words, your horizontal asymptote is at 0. It's on the x-axis. Botan, bigger on top, then no horizontal asymptotes, and then eats DC. If the exponents are the same, then you divide the coefficients, and thus that will help you remember how to figure out the horizontal asymptotes. So let's go ahead and put this stuff to use. Let's start off by graphing y equals -2 over x squared plus 2. And we want to state the domain and range. So I'll start off and let's identify our asymptotes. That's always a good place to start. So the vertical asymptotes can be found simply by looking for when we set the denominator equal to 0. So let's do that, vertical asymptotes. So I'm going to say an x squared plus 2 is equal to 0. Thus, x squared is equal to -2. Thus, when I take the square root of both sides, I'm going to have x, which is equal to the square root of -2. Now, we're left with an imaginary number here, so therefore there's going to be no vertical asymptotes to graph, so I'm not going to worry about that. And looking at the numerator is -2, and we can't have any zeros there, so therefore there's not going to be any x-intercepts. So now let's look at those horizontal asymptotes. Now I notice that the exponent here is 2, and so it's bigger on bottom. So that's Bobo, bigger on bottom. So therefore we're going to have a single horizontal asymptote at on the x-axis right there. So now we would just plug in points and get whatever remaining points we can. So what we need to be able to do before plugging in points is find the horizontal asymptotes, the vertical asymptotes, as well as the zeros. So then we can just plug in some points, and thus it's going to look, it'll look like that. Okay, and we can see that it's going to be following along that single horizontal asymptotes, and there's no break. So thus my domain, so if I write out my domain is x, where x is such that it's all real numbers. There's no restrictions on my domain. And my range, y is such that y is less than 0. So there I have my domain and range according to this graph. Okay, and knowing those asymptotes is going to really help us define our domain and range as well. Okay, let's look at another one and see how it goes. So let me start off looking for those vertical asymptotes. So my vertical asymptote, I'd say x squared minus 4 is equal to 0. So this x squared is equal to 4, and therefore x is equal to, so I take the square root of both sides, and since I'm putting in a square root of both sides, it's going to give me 2 plus or minus 2. So recall, because I'm pulling in a square root, I'm going to do plus or minus, since I do that when there isn't a square root already. So I'm pulling it in, so we have to find both, plus and minus. So I'm going to go ahead and draw those in. So one at -2 right here, and one at +2 right here. Okay, let me move on to the horizontal asymptote. Let's do this on the side. Okay, so I look at what we have, and it looks like it's equal. It's the same. So that's the eats. Exponents are the same, and so that's DC, divide our coefficients. So this is our eats DC. Our coefficients being y equals -1 over 1. So y equals -1, and that's where my horizontal asymptote is going to be. Please label where you're finding the vertical and horizontal asymptotes when you work this out on your paper, so it's clear, as well as when you find the zeros. So when I find the zeros, that's when I'm going to just say -x squared. So I set the numerator equal to 0. So I'll divide both sides by -1, and then take the square root. Now I'm going to do plus or minus, though it technically doesn't matter because it's 0. So thus, x equals 0. So let me go ahead and draw those in. So a horizontal asymptote at -1, and x equals 0. So that's the one place where it's going to have an x-intercept. And now let's go ahead and we'd pull in some other points. We'd substitute in values of x. I'm not going to do that here because I know you're fully capable of doing that. And thus we can see what the graph is going to look like. And it follows along those asymptotes that we predefined, and it goes through that point that we found with the 0. So hey, it's pretty cool when it works like that. It's pretty neat. It's exciting to me anyway. All right, let's do one more. So here we're going to graph x squared minus 2x plus 1 over x plus 2. Okay, so this one's going to take just a little bit more, not much. Let's again start with the vertical asymptote. And so that's when we're going to set our denominator equal to 0 because we can't divide by 0. So thus x equals -2 as my vertical asymptote. So let's sketch that in. Okay, so we just have 1. This might be an interesting looking graph. And the horizontal asymptote, again, if I look at my exponents here, I can see that this one is 2, and the degree in this polynomial is going to be 1. So therefore, it's bigger on top. So that's going to be bottom, bigger on top. And the n stands for no horizontal asymptote. So we only have one we need to worry about. So let's get our zeros. Okay, so this is where we will set our numerator equal to 0. So in other words, we're solving this quadratic. Hopefully this one can be factorable, make our lives a lot easier if it is, and I believe it is. So this is going to be x minus 1 times x minus 1. This is going to be a special product property here, so it's not going to be a hard one, or you can just factor it. So therefore, x would have to equal 1. So we'd said use the zero product property. You know how to do that. So therefore, it should cross right there. And then we would pick out some points and substitute them in, and then we would plot our graph, and it would look like that. And look what we have there. That's awesome. That is graphing rational functions. Until next time, I'll see you on the flip side.